Going on, guys. In this video we are going to see an example of initial value problem with Laplace transform. In this particular problem we have asked to find out the Laplace transform for this given function. The function is 2y double prime plus 3y prime minus 2y is equal to t e power negative 2t, and also we have the two initial values, y of 0 is equal to 0, y prime of 0 is equal to negative 2. And when we do the Laplace transform we use these three equations. First, when we have double prime we replace that one with s square f of s minus s of f of 0 minus f prime of 0. When we have f prime we replace that one with this one, and after the equal sign, if you notice, we have t e power negative 2t. So when we have that pattern we replace that one with this one. Okay, and after we replace and simplify and solve for this one, we are going to use the inverse Laplace transform. So when we do the inverse Laplace transform we use these terms. Okay, this is going to come after, but let's do this part first. First we are going to turn this one into this pattern. Here we have 2y double prime. Okay, y double prime we are going to use the first one. This is for double prime, but if you notice, this is f double prime, right? When we have f double prime, this is capital F small f small f, but when we have y double prime we replace this one with capital Y small y small y. So this is going to turn into s square capital Y of s minus s small y of 0 minus y prime of 0, and then we have 3y prime. Okay, when we have y prime we replace that one with this second one, so that's going to be s f of s, and in our case that's going to be capital Y of s, and then minus small y of 0, and after that we have this minus 2y. So when we have 2y alone, that's going to be just capital Y of s, that's it. And this 3 multiply this one alone, right? These two things alone, because 3y prime, this is for y prime, and this one alone. After that we have equal to t e power negative 2t, and if you look at this one, the t power is the n value, so here we have to have n factorial, and if you look at our t power is 1, right? So we are going to have 1 factorial on top, and in the denominator we are going to have s minus a is the power of e, multiply the t value. In our case that is negative 2, right? So a is going to be negative 2. Here we are going to have negative 2. That's going to turn this one into positive 2. So this is going to be s plus 2. And then we power this one with n plus 1. In our case n is equal to 1. So 1 plus 1, that's going to be 2. Okay. Now let's simplify this one. We have two initial conditions. We have y of 0 is equal to 0, and also we have y prime of 0 is equal to negative 2. And if we replace that one here, this is going to become s square capital Y of s minus s times 0. Then y prime of 0 also 0, so this is going to be just 0. And then here we have 3 s y of s, and then we have y of 0, that's going to be just 0. After that we have negative 2 capital Y of s, and 1 factorial is just 1, so this is going to be just 1 over s plus 2 square. Okay, now let's simplify this one. Here we have 2 times s square capital Y of s, and then s times 0, that's going to be 0, so we don't even have to write that one. And y prime of 0, okay, y prime of 0, I made a mistake here. Y prime of 0 is equal to negative 2. Here we have to have negative 2. This one is negative 2, so negative 2, right? So positive 2, negative 2, positive 2, then plus 3 s y of, okay, let's write this one here, plus 2, then plus 3 s times y of s, that's going to be just 3s y of s, but let's keep it in the bracket for now, s y of s. And then after that here we have 2 y of s, that's equivalent to 1 over s plus 2 square. Okay, now let's simplify this one. Here we are going to have 2s square y of s plus 4, and then here we are going to have 3s capital Y of s minus 2 y of s. After the equal sign we have 1 over s plus 2 square. We can move this 4 to the other side because we are going to take y of s common. Before we do that, let's take this 4 to the other side. So this is going to be 2s square capital Y of s plus 3s capital Y of s minus 2 capital Y of s is equal to 1 over s plus 2 square. If we move this 4 to the other side, that's going to be negative 4. And also if we take s plus 2 square common denominator, we multiply the top and bottom by s plus 2 square. So this is going to be s plus 2 square on top and the bottom. So we can simplify this one, okay? So this is going to be s plus 2 square over s plus 2 square. And let's take y of s common here. If we take y of s common, this is going to be, in the bracket we are going to have 2s square plus 3s minus 2. Okay, in the other side we are going to have 1 over, okay, let's add them together, 1 minus 4s plus 2 square. And if we multiply this one, s plus 2 square is going to be s plus 2 times s plus 2. S plus 2, if you multiply you will get s square plus 2s and again plus 2s, and then we are going to have plus 4. So if you simplify this one, this is going to turn into s square plus 4s plus 4. So we can replace this s plus 2 square with s square plus 4s plus 4. So this is going to be 4 times s square plus 4s plus 4 divided by s plus 2 square. Okay, now let's continue this part right here. Let's use a different color because we have so many things going on. And we are going to multiply this one. Before I move this to the other side, or we can keep this one as 1 over this term, because dividing this one is same as multiplying this one by 1 over this value, right? So we can write this one like that. So y, capital Y of s is going to be equivalent to 1 minus 4 times s square, that's going to be just 4s square, plus 4 times 4s, that's going to be 16s, plus 4 times 4, that's going to be 16, divided by s plus 2 square, or we can just like multiply this one with this. So this is going to be 2s square plus 3s minus 2. Okay, now let's try to simplify this one. This one we can add this one with this, but okay, this whole thing I should put a bracket here, because this one is going to be turned into, the whole thing is going to be turned into different values. Okay, let's put a bracket here. So this is going to become 1 minus 4s square minus 16s minus 16. If you add this one here, this is going to be plus 15. So we can write, instead of 1 minus 16, we can put plus 50 minus 15 minus 15, and here we can factor this one. If you factor this one, you will get, let's try to factor this one, because when you multiply you have to have negative 4, when you add you have to have plus 3, so 4 minus 1 will work, right? So 2s square plus 4s minus s minus 2, and here we can take 2s common, that's going to become 2s plus 2, and then if we take minus 1 common, this is going to be s plus 2. So we will have 2s minus 1 s plus 2. So this is going to be our factor. So we can write s plus 2 square times 2s minus 1 times s plus 2. So s plus 2 times s plus 2 square, that's going to turn into s plus 2 cube, because both of them are same thing, right? So we can, instead of writing like that, we can replace this one with s plus 2 cube. Okay, so now we can find this solution using partial fraction decomposition. Now to do that we need some space, but in this case I'm gonna write the final answer, because if you do the partial fraction decomposition, it's going to take a long time and long space, right? So I'm gonna give the answer because that's just easy method. Okay, let's get rid of these things. So here we had to do the partial fraction decomposition of this one. So if you do the partial fraction decomposition, let's write this function first. Y of s is equivalent to negative 4s square minus 16s minus 15 divided by s plus 2 cube times 2s minus 1. So when you do the partial fraction decomposition, you had to, when we have s plus 2 cube, we had to write each term, like we had to write s plus 2, then s plus 2 square, and then we had to write s plus 2 cube. We had to write everything, right? So that's that one you have to remember. Let's go ahead and write this one. Here we are going to have a over 2s minus 1 plus b over s plus 2. Then we are going to have c over s plus 2 square, and then we are going to have d over s plus 2 cube. So this is our partial fraction decomposition. Now you can solve for a, b, c, d, and if you solve this one, you will get a is equivalent to negative 192 divided by 125, and then b will be equivalent to 96 over 125, and then c will be equivalent to negative 10 over 125, and then d will be equivalent to negative 25 over 125. So we can go ahead and write our function. So y of s is going to be equivalent to a over s 2s minus 1, but to avoid this like too many constant inside, we can take the 1 over 25 common, 1 over 125 common. If we do that, this is going to be 1 over 125 multiplied by a, that is 192, right? So 192 divided by 2s minus 1 plus b is going to be 96, 96 divided by s plus 2, then plus c is going to be negative 10, so we put negative here. Okay, let's put negative here. So this is going to be negative 10 over s plus 2 square. Then instead of d, we replace that one with negative 25 over 125. So this is going to be negative 25 over s plus 2 cube. Okay, now we are going to use the inverse Laplace transform. To do that, we have to use these two methods. When we have 1 over s minus a, we replace that one with e power a t. When we have n factorial over s minus a power n plus 1, we replace that one with t power n e power a t. Okay, that's the one we are going to do right here. So this y of s will turn into y of t. Okay, so we keep this 1 over 125 here, 1 over 125, and then 192 over 2s minus 1. Okay, instead of writing like that, we can take this 190, because if you notice, we have to have 1 over s minus number. So we have to have that pattern here. In order to get that pattern, we have to take 192 common, and also we have to take this 2 common, because in the bottom we have just s. We shouldn't have anything in front of this s. So we have to also take this 2 common. If you do that, you will get, okay, I made a mistake here. This should be negative 192, because in the a value this is negative. So negative 192 over 2 common, and if you do that, that's going to give you 1 over, and this is going to become s minus half, s minus half, right? Because half times 2, that's going to give you 1, so s minus half. And let's do this one for the other things. Here we have 96. If we take 96 common, this is going to become 1 over s plus 2, and here we have negative 10 common, that's going to become 1 over s plus 2 square. But when you have more than one power, when we have one power, we keep this one e power at, we transform this one into e power at. But when we have more than one power, we have to have the factorial on top. In our case, this is 2, right? So we have to have 1 less factorial. When we have n plus 1, we have to have n factorial. So here we have 2, so we have to have 1 power reduced, like that's going to be 1 factorial. Okay, so here we have to have 1 factorial, and let's look at the next one. Here we have 25. If we take 25 common, this is going to be 1 over s plus 2 cube. But if you notice this pattern, we have to have n plus, like minus 1. If this is n plus 1, so we have to have 1 less in the factorial. We had to have 2 factorial, but we have 1 right here. To get the 2 factorial, what we can do is we can write this one as 2 factorial over 2 factorial. That's equal to 1, right? So, but we only need 1 factorial right here. So we have to get rid of this bottom 2 factorial. To get rid of this one, what I'm going to do is I'm going to keep the 2 factorial on top here, and the bottom 2 factorial I'm going to keep it outside. Okay, in that way we can transform this, we can do the inverse transform. Now let's go ahead and do that. So this is going to become 1 over, let's write it with a different color, 1 over 125, and here we have negative 192 divided by 2, that's going to give us 96, and then s minus half. So when we have 1 over s minus a, that's going to turn into e power at. In our case, a is equal to half, so this is going to be e power half t. Okay, so this is going to turn into e power half t, and then here we are going to have 96, 1 over s plus 2. S plus 2 can be written as s minus minus 2 because we have to have minus here, we shouldn't have plus. So instead of writing like this, I can write this one as s minus minus 2. In that way we will get, here we will get e power negative 2, let's write this with same color, e power negative 2t, and then here we have negative 10. Now to transfer this one, we have to do the second one. Second one is t power n, e power at. N is the factorial, the value in front of factorial. Here we have 1, so this is going to be just t, and then e power at. A is the value in the denominator. Again, this one is same as s minus minus 2. Okay, minus minus 2. So now we can go ahead and write this one in this pattern. So this is going to be t times e power minus 2 t. Okay, now let's go to the next one. Here we have 25 over 2 factorial. 2 factorial is 2 times 1, so that's going to be just 2. So this is going to be 25 divided by 2, and then 2 factorial. Now we are going to transform this one. This is going to be t power n. In our case, n is equal to 2, so this is going to be t square, and then e power at. In our case, a is going to be minus minus, because we shouldn't have plus here. This should be minus minus 2. Okay, same as plus. So this minus 2 is going to be power, so e power negative 2t. Okay, so this is our Laplace transform, and that's how we do the Laplace transform for the when we have initial value problems. I hope this helps. Thanks for watching.